Musical talent and a passion for research are by no means contradictory.
A femtosecond laser is essentially similar to a bassoon or another musical instrument. In both cases, there's a resonator in which various frequencies can build up. Often that's a fundamental frequency. When these frequencies are combined with the right phase, then you get short pulses.
These men don't work in oil, but rather in light. Their world is the solid-state laser. Their secret weapons are curiosity, perseverance, and an unshakable faith in their own achievements. The Fraunhofer Institute for Laser Technology ILT in Aachen. Interdisciplinary team members from science and business join forces here in a research network. 13 creative minds and a vision that's become reality.
We're the world record holders because this laser concept lets us achieve the highest mean output performance at widely varying pulse lengths, both in ultra-short pulses and at medium pulse lengths in Q-switched operation. Here we have a kilowatt or 400 watts of output power. That's a world record. That's great.
The newly developed laser platform works with the so-called InnoSlab amplifier. The trick here is the special cuboid geometry of the laser crystal. This was a groundbreaking innovation and one that helped the femtosecond laser make its breakthrough in practice in a wide variety of fields.
Here we're building a system that will be used for climate research, or is a building block in that work. It will be used in a measurement system at the German Aerospace Center in the Institute for Atmospheric Physics. It's an airborne system, flying with a new HALO aircraft, Germany's new research airplane. It's used to measure methane distribution. And with a second system, almost identical, CO2 will be measured.
Research and business now have a high-efficiency instrument that can sharply reduce processing times in high-precision manufacturing, while at the same time protecting the workpiece.
The application we're working on here uses a high-power picosecond laser to open the skull. The major advantage here is that, compared with mechanical procedures, this makes for far greater safety.
Safe, efficient, and economical as well. An unbeatable combination for the patient's welfare.
The major costs are encountered in post-operative care. It's fairly simple. You have to realize that there are about 300,000 operations in Europe. 10% of those result in complications simply because the periosteum is injured in mechanical separation. And that's something you can prevent entirely with the laser.
That's a convincing achievement. In the meantime, this innovative laser concept has come to be marketed on a broad basis. The people at Edgwave, a startup company in Aachen and a spin-off of the Fraunhofer ILT, are looking forward to the new challenges. The company's founder, Dr. Keming Du, along with Daijun Lee, Alexander Schell, and Rüdiger Haas, made a decisive contribution to the development and the marketing of the new beam source.
Edgwave is the first company to work with the technology and to create market-ready products. So Edgwave first believed in this concept and secondly, built it into a product.
This new precision tool from Edgwave is of particular value when processing highly sensitive materials.
What we see here is cutting chemically hardened glass, used in display industry, for instance, in iPhones, mobile phones, and TV sets. The chemical hardening of the glass is the real challenge. You need very short pulses here. In this example, it's a picosecond laser with mean output power of 40 watts.
Klaus Schnitzler and Thorsten Manns of Amphos are also members of the development team. Amphos in Aachen is another spin-off of the Fraunhofer ILT. Amphos builds ultra-short pulse laser systems with extremely high mean output power and pulse energy.
Amphos was the first to demonstrate that a high-output laser unit in the ultra-short pulse range could be built for user-friendliness.
Many applications become economical only with the use of Amphos laser systems. The startup can be proud of many superior achievements.
Our laser has the highest output of all femtosecond lasers, all around the world. We have output power of 500 and even 1,000 watts at pulse duration of less than 1 picosecond.
Following intense research work and despite some setbacks, the masters of light have reached their goal: a new laser platform. This is a development the laser world has long been waiting for. Congratulations!